Day 297 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 31, next permutation. The difficulty level is medium, but don't even worry because we're going to keep the solution as simple and easy to understand as possible, y'all. But before we get started, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description and get you some. Now let's see what the question says. Question says, a permutation of an array of integers is an arrangement of its members into a sequence or linear order. For example, R equals an array of integers 1, 2, 3. The following are all permutations of R. 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. The next permutation of an array of its integers is the next lexicographically greater permutation of its integer. More formally, if all of the permutations of the array are sorted in one container according to their lexicographical order, the next permutation of that array is the permutation that follows it in a sorted container. If such arrangement is not possible, the array must be rearranged as the lowest possible order, i.e. sorted in ascending order. For example, the next permutation of R123 is 132. Similarly, the next permutation of R231 is 312, while the next permutation of R321 is 123 because 321 does not have a lexicographical larger rearrangement. Given an array of integers nums, find the next permutation of nums. The replacement must be in place and use only constant extra memory. So, y'all, now that we've read the question, let's go ahead and get into these examples. But before we get into the examples, let's make sure we know what lexicographically actually means. So lexicographically, it's similar to alphabetical order. However, we're dealing with numbers, so it's a little tricky to understand, right? So as you can see, let's look at this example first that they give us in the question, right? So they give us 1, 2, 3, then they give us all of the permutations of 1, 2, 3. So as you can see, when we're creating all of these permutations, and these permutations right here are in lexicographical order. So as you can see, when they give us all the permutations or different combinations of 1, 2, 3, first we do all the possible combinations of 1, 2, 3 starting with 1. So we do the 1, 2, 3, and then we do 1, 3, 2. These are the two possible combinations of 1, 2, 3 when we start with 1. Now that we did the 1, now we're going to do the 2s, all the possible combinations starting with 2. So we do 2, 1, 3, then we do 2, 3, 1. Now that we did all the possible combinations starting with 1, then we did all the possible combinations starting with 2. As you can see, that's in order. So as you can guess, now we're doing all the possible combinations starting with 3. So those are 3, 1, 2 and 3, 2, 1. Now, what you need to be aware of or keep in mind is it's still just because we start with 1 or we start with 2 or we start with 3 does not mean that we're done, right? So now that we did all the numbers that start with 1, the first permutations of the that start with 1 is we need to do all the combinations that start with 1, 2. In this case, there's only one combination that starts with 1, 2. But say it was let's come over here and say it was 1, 2, 3, 4, right? So say it's 1, 2, 3, and 4. So now we would have to do all the combinations. It'd be more combinations that start with 2. So first we do 1, 2, 3, 4, boom. Then we do 1, 2, 4, 3, boom. Then we would do 1, 3, 2, 4, boom. Then we do 1, 3, 4, 2. Then it go 1, 4, 2, 3. Then it go 1, 4, 3, 2. So as you can see, this is just all the permutations starting with 1. It would be more than we do for 2 than we do for 3. But as you can see, the second number is important as well, because then when we're doing all the permutations that start with 1, then we start with all the permutations that start with 1, 2. After we find all the combinations that start with 2, Then we do all the combinations that start with 3 because we already did 2's. Then we do all the combinations that start with 1 3. Then we do all the combinations that start with 1 4 after we did all the combinations that start with 1 2 and 1 3, right? So as you can see, the next number is just as important as well. And same as you can see here, these numbers are in lexicographically ordered too as well, because then we have to do, when we're doing all the combinations of 1 3, we have to make sure that the numbers after 1 3 are in ascending order, right? Or we do all the combinations after 3 in ascending order, and then we do 1 2 1 3 2, then we do 1 3 4, then we do 1 4 2, then we do 1 4 3. You know what I'm saying? As you can see, I hope this helped to make more sense to y'all. It's like, think of it in alphabetical order, but it's with numbers, so I know it's a little tricky, right? But once again, first we do all the combinations that start with 1, then we do all the combinations that start with 2, then we do all the combinations that start with 3. But each combination should be in lexicographical order as well. So then it'd be all the combinations that start with 1 2, then we do all the combinations that start with 1 3, and so on and so on. So now that we know what lexicographical means, I hope that made sense to y'all. Let's go ahead and take a look at these examples so we can see exactly what it is that they want us to do, right? So in example 1, we have the input nums equals an array of integers 1, 2, 3. The next permutation after 1, 2, 3 in lexicographical order would be 1, 3, 2, because we already did all the combinations that start with 1 2, so now we do combinations that start with 1 3, right? And as you can see, it goes 1 2 3. The next one after 1 2 3 is 1 3 2. Boom. And that's what we want, y'all. We're not returning all the permutations of 1 2 3. We're just returning the next permutation that comes after 1 2 3, which in this case would be 1 3 2, as you can see up here. The next one after 1 2 3 is 1 3 2. That's the next one. Then similar in example 2. So in example 2, it might get a little tricky if they throw a trick question our way, because in example 2 we have the input nums equals an array of integers 3 2 1, and this is the last permutation of 1 2 3, right? As you can see up here, this is the last one after we do all of the permutations. So since it's the last one, we're just going to do a loop around, right? And we're just going to start over from the beginning. And that's why 1 2 3 would come next. And as you can see, the output is 1 2 3. So just imagine that we're right here at the last permutation. We want to find what comes next. And since this is the last, imagine it's in a circle, and we're just going to loop around and start from the beginning over and start all over again. That's why the next one is 1 2 3. Now let's look at example 3. In example 3, we have the input nums equals an array of integers 1 1 5. The next one would be 1 5 1, because we already did this combination 1 1 5. So there's only one more combination we could do, which would be 1 5 1. There's no other permutation that will come after that when we're dealing with the permutations that start with 1, right? We're not dealing with permutations that start with 5 yet. We're still on the permutations that start with 1. And this seems like it'd be the first one. So we do 1 1 5, then we do 1 5 1, because we already did the 1 5 right here. So now we're doing the 5 1 right here. Boom. So I hope that made sense to y'all. I know that's a lot to wrap your mind around. That's why I hope it made sense. Just make sure you learn it and study it. Do what you need to do to make sure you understand what lexicographical actually means, because if you don't understand the question, you most likely are not going to understand the solution, and that's not what we want. We want to be able to understand the solution in the code that we're writing. So now that we understand the question, let's get into the fun part, the actual code, y'all. So the first thing we need to do is we need to check if the array has only one element, and if that means there is no next permutation. So in order to do that, we could just come right here. We could say guard nums dot count, boom, is greater than 1. Else we could just open up the brackets and we can return, boom, just like that. Then we'll come underneath that And now we need to find the first decreasing element from the right. So we're going to start from the second to last element and move left until we find a decreasing pair. So since we need to compare two numbers, we're going to start from the second to last so we can compare these two numbers, right? So we can compare the second to last and the last. So in order to do that, we're going to declare a variable. We'll call it I. We'll set that equal to nums.count minus 2. That's going to get us the second to last element. Then we're going to say while I is greater than or equal to 0, and two and signs, nums square bracket I plus 1 is less than or equal to nums square bracket I. Come over here. We'll come over here. We're going to open up the brackets and we're going to say I minus equals 1. And that's going to help us move to the left. Now, we're going to come right here. And if no such element is found, the array is in descending order. And we're going to reverse the entire array to transform it into the smallest permutation. So to do that, we're going to use another guard. We're going to say guard I is greater than or equal to 0. Else, we're going to open up the brackets. We're going to say nums dot reverse, put the parentheses, come under that, and we're going to say return. Boom. Now we need to find the smallest element on the right side of I that is larger than nums of I. So we're going to come right here. We're going to say declare a variable called j and set that equal to nums.count minus 1. Come right here. We're going to say while nums square bracket j is less than or equal to nums square bracket I. We're going to come right here. We're going to open up the brackets. We're going to say j minus equals 1. Boom. Now we need to swap nums I and nums j to create a larger permutation. So we could just come right here underneath the while loop and we could say nums dot swap at, open up the parentheses I comma j. Now we're not done yet because we still need to reverse the elements. So to do that, we are going to, first we're going to come outside this function. We need to create a helper function to help us do that. So we'll say private func, because and it's also important because it needs to be, remember, it needs to be in place. So in order to do that, we are going to come right here. We'll say private func reverse, open up the parentheses. We're going to say underscore nums colon. That's going to be an out. Open up the brackets. We're going to say int. Boom. An array. It's going to be an array of integers. Boom. We're going to say comma. Then we're going to say underscore start colon. That's going to be an integer as well. We're going to come outside of that and we're going to open up the brackets. We're going to declare a variable called left. We're going to set that equal to start. Then we're going to declare another variable called right. We're going to set that equal to nums.count minus 1. Boom. Now we need to reverse the subarray from start to the end of the array to ensure the next permutation is the smallest possible. So in order to do that, we could just say while left is less than right. We're going to open up the brackets. We're going to say nums.swap at, open up the parentheses. We're going to say left, comma, right. Then we're going to come underneath that and we're going to say left. We're going to increment left by saying left plus equals 1. Come underneath that. We're going to say right minus equals 1. Boom. Now we're going to come up here and we just need to call that function. So we're going to say reverse, open up the parentheses. We're going to say and nums. When we're dealing with and out, we need to put this and sign. Oh, that should be an and sign. We need to put this and sign right here when we're dealing with and out. Then we're going to say, come outside the nums, we'll say comma I plus 1. Now that should be all she wrote, y'all. Let's go ahead and run it. Okay. Oh, sorry, y'all. It should be equal white space. Sorry about that. Let's go ahead and run it again. See what happens. Let's see. And it's accepted, y'all. So let's go ahead and submit it. Make sure it stays accepted after we submit it. because we all know how this LeetCode stuff can be. Ooh, look at that, y'all. Y'all know I love those numbers right there. 0 milliseconds beats 100% of users with Swift. That's what I'm talking about. Excuse me. That's what I like to see, y'all. And I hope y'all learned something today. But before we leave, make sure y'all get one more look at the code. That's the top half. Get the top half of the code. That's the top half. Read it, learn it, love it. Boom. Now get the bottom half. Read it, learn it, love it. And yeah, y'all, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.